Hi, everyone. My name is Cadence Walsh. I am a graduate student at University of Wisconsin-Madison in the Department of Animal and Dairy Science. I am also the assistant manager at the Swine Research and Teaching Center up in Arlington, Wisconsin. And today I'm just going to give you a brief overview of our current research project on the efficacy of using ammonium chloride supplements during crisis management to stop growth in various ages of pigs. This project came into existence in the spring of 2020, once COVID-19 hit and started resulting in slaughter plants to shut down. Like all other producers, we were also affected by this. I was actually weighing pigs for a semi that was supposed to go the next day when I received a call from our hog buyer saying, "Hey, sorry, we can't take your load tomorrow. Hopefully you find somewhere else for the pigs to go. Otherwise, I will be in contact as soon as I can about getting your load rescheduled." And so that led to a conversation between Dr. Tom Crenshaw, myself, and Jamie Reichert, that's up here at Swine Research and Teaching Center. And we were trying to think of some type of strategy in order to help producers facing this kind of situation. Obviously, with African swine fever kind of looming over as it's been spreading across the globe, this was actually kind of timely with COVID-19 happening as well, and really brought to our attention the potential challenges that we could be facing in the future, because it's probably not the last time that it's going to happen. So looking at these crisis situations of either animal stop movements or slaughter plant shutdowns, whether it be from a pandemic like COVID or for an animal disease outbreak, biggest problems we were facing is obviously nowhere to market the pigs and provide space for that inflow of new piglets. Obviously, sows are already bred continuously, sows are being bred. And so we needed a place for piglets to be, and without that constant flow of pigs going out to market, new pigs coming in, it obviously causes major concerns. And so producers are faced with this need to reduce their production and economic loss with limited information to make those decisions. And there are some other research projects that have been going on. Iowa State University did a research project last spring as well, looking at ways to slow growth. But at this point, like reliable methods to slow the growth are not yet established. And so that's why there are many folks out there that are working really hard in order to try and come up with methods that can help us during these challenges. One of the things, reducing nutrient concentrations can reduce growth like 10 to 20%, but that's not enough for this level of crisis management. So we knew we needed to think of something else. Like most producers, our top concerns right off the bat to address would be aggressive behavior, feed costs, welfare concerns, carcass quality, and time to market. We felt like those were the top priority areas that we needed to address. And so we asked the question of, could the use of ammonium chloride be the solution? Our nutritional strategy objectives are, we knew that we wanted more than 50% growth reduction for 2 to 4 weeks with no adverse health or welfare effects on the pig. Cost of feed for the hold phase must be reduced. Pigs released from the hold diet must recover with minimal negative consequences to the carcass value and time to market. Timely implementation if a stop movement is ordered. Obviously, if we've got pigs ready to go to market, say the next day, like the situation I was in, we don't have a lot of time to be sitting around trying to figure out what we were going to do or how we were going to do it. We want something that can be like, okay, we know our plan, we need to be able to do this, whatever that timely implementation can be different depending on the producer. But we want to make sure that it's available and ready to go. And so our strategy to meet these objectives is the use of ammonium chloride in feed or water to supplement water supply to various growth stages. So our ongoing research project, we actually were able to apply for submit a proposal for a grant through the USDA, which we did receive. And so that initial proposal contained these 3 different aims. And so our aim 1 was to identify the optimal ammonium chloride dosages for water and feed applications. Ammonium chloride is not currently used in swine feed, which makes sense because obviously if it reduces growth, typically no one would want to be doing that. And so we were trying to go based off of previous research that's been done in rats and humans in order to identify this optimal dosage. And then from there, once we identified that, we were going to move into aim 2, which would be to apply the dosage level determined in aim 1 and compile data at various pig weights during hold and recovery phases and at market to verify growth reduction and carcass quality. And this is going to be the part of the project that's done on a larger scale out at the Swine Research and Teaching Center in order to have more observations per treatment. And then from there, we would move into aim 3, which is to compose a dynamic economic model to assess the impacts of ammonium chloride and assist both large and small scale producers in decision-making. And this is in collaboration with the UW Ag and Applied Econ professors, Dr. Jean-Paul Chavas and Dr. Andrew Stevens. This graph here is essentially a summary of the information that we knew we needed to collect, especially in this recovery phase. Once we knew that the ammonium chloride could hold the pigs for 4 to 6 weeks, we needed to know whether or not the pigs were going to have compensatory growth versus catch-up growth. So this black line here would be just a normal standard growth curve for pigs. And so here we have our hold for 4 to 6 weeks. And the question we're trying to answer is whether or not the pigs are going to compensate from being held and not eating as much, and whether or not that's going to result in, what level of compensation. Obviously, this is just a graph that we came up with to try to visualize what we're looking for. This is not based on actual data that we've collected yet. But, looking at this, the compensatory growth, we would imagine obviously at an increased growth rate compared to normal growth. And then at some point, do they achieve over the normal growth and come back? There was a lot of questions there, as well as whether or not there would even be that compensation, or if the pigs would just recover at a catch-up growth, which would run parallel to this normal standard growth curve. With that, obviously comes more questions of, here, if this is typically our age and our weight that we're trying to market the pigs, if there's compensatory growth, will they have achieved that weight at this time point? At what area on this line will that be? And again, the catch-up growth down here, they're going to be lighter at that time frame. Here, they'll reach maybe more of a target weight, but it's going to be 3 weeks out. This is where the economic model is going to come in to help with that decision-making of, do we send lighter pigs earlier? Do we hold on to them? And trying to just make that more specific to a producer so that they have the ability to make that decision, hopefully a little bit easier than they would have without the research that we're doing. So some of our preliminary experiment discoveries. We did an experiment with 2% ammonium chloride in the feed with standard NRC nutrient levels, and that resulted in less than 50% growth reduction. And that raised the question of, if these pigs are being held at a certain weight, do they really require the same nutrient requirements as a growing pig? So now, we're looking at maintenance level requirements versus growing. And so we moved into another experiment that had 2% ammonium chloride in the feed with reduced nutrient levels, and that resulted in over 50% growth reduction. Obviously, some of that growth reduction comes from the reduced nutrient levels in addition to the ammonium chloride. And so we did another preliminary experiment addressing the question of how much does the diet with lower nutrient levels reduce the growth without ammonium chloride. And with that study, we discovered that it was about 10 to 20%, which I had mentioned in a couple slides prior. And from there, with that information, we moved into our current project. So our AIM 1 was held on campus at the livestock lab. And that was a smaller number of 25 kilogram pigs. And we basically what we're trying to achieve there is figuring out what that ideal dosage is. And so we found out that the targeted growth reduction was achieved at 2% concentration in the feed and somewhere between 1 and 1.25% concentration in the water. And that was without observing any negative effects during the hold phase. And so that project had 3 different dosage levels. It was kind of what we anticipated or predicted would be the ideal dosage. And then on the lower and higher end of that, just in case to kind of leave room for error in that calculation. And so those were the percentage levels that we determined were optimum from that study. So we then moved into AIM 2, which is currently in progress. And so we are doing that up at the Swine Research and Teaching Center with a room of pigs. And so at this point, we have found that in both the 25 kilogram and the 50 kilogram pigs, over a 4-week time period, we were able to reduce the growth over 75%. And if I can draw your attention to this photo over here, these pigs on the left are the standard control diet pigs. And then these on the right are the 50 kilogram pigs that were held for 4 weeks. And this is actually taken at the end of the 4 weeks. We just switched them to the recovery diet yesterday. And so I took this photo that same day. And so this is where they were held, still right around 50 kilograms, as you can see, compared to our control pigs. Hopefully the picture doesn't really do it justice. It's a lot easier to tell in person, but hopefully you can see that there is a noticeable size difference. There's also a little bit of coloration difference between the pigs. But if you can see back here, their pens are a lot cleaner, which would be anticipated as they are not eating as much. Their feed intake is lower compared to the control pigs. So actually they ended up being a lot cleaner. But then they're just as active as our control pigs. We did not see an increase in tail or ear biting or any type of aggressive behaviors. Other than the size difference, it would actually be pretty difficult to tell that there is anything different between the pigs that were held on treatment versus the control pigs. As far as any recovery data that we've collected so far, we do know in the 25 kilogram pigs, it took them 2 weeks to recover and advance to the next feeding phase, which was 25 kilograms. So they came off at 75% reduction. So they were a little bit over 25 kilograms, but it only took them 2 weeks to get up to 50 kilograms versus 4-week time frame, which is what takes the control pigs to get from 25 kilograms to 50 on a normal diet. Again, we just switched the 50 kilogram pigs from their whole diet yesterday, so we don't have that data yet, but that will be part of what we're continuing with the project. This graph also kind of just summarizes what I just said about the 25 kilogram pigs. So over here we have the growth for the pigs while they were on treatment. These black bars are the control pigs. So you can see for the first 4 weeks, they were somewhere, they kind of leveled out around between 0.9 and 1.2 kilograms, and then they remained fairly consistent right around that 1 kilogram up until this point at week 7. And then these red bars are the pigs, the 25 kilogram pigs that were being held. And so here you can see the first week they did not gain anything. And then they did increase a little bit. This was about 0.2. And then around the third week, they got up to 0.3 and then remained consistent at that 0.3 growth rate for week 4 as well. Week 5 is when they got switched to their recovery phase. Again, it's just a standard diet for that size pig. And so here we can see that first week, they actually shot up to 1.4 kilogram average daily gain. And then after that first week, they kind of came back and leveled out more to where the standard control pigs are, right around 1.1, 1.2. So from this data up until this point, we do see that there is some compensation here where they achieve higher growth versus the control pigs. And then they have been leveling out. So far, they're remaining consistent here. We will see, we'll continue weighing them, carry out to market to see if that changes at all. Down here is the picture of the pigs. So these were actually our pigs that were held at 25 kilograms versus our standard pigs, the control pigs. And so you can see that they are obviously smaller because they were held. They're at different phases, but the pig, I mean, they otherwise look normal. Their coloring is the same as the control pigs. They're just a little bit smaller from still trying to work in that recovery phase. To be continued, we have to complete AIM 2. We are currently recovering those 50 kilogram pigs, and we also started holding 75 kilogram pigs for 4 weeks to collect data on both the hold and recovery phase. And then from there, we will move to harvesting the pigs at about 125 kilograms, and we will do that at the UW Meat Science and Animal Biologics Discovery Facility to collect carcass data. From there, we're going to take all of that data that we've collected and analyze it to develop an economic model reflecting the impacts and economic efficiency of supplementing diets with ammonium chloride in crisis situations. This is the part that's really important for producers and where we can apply that to helping the industry when faced with challenges like this. Our future projects and further questions and concerns. After we complete the feed study, we would like to move into using ammonium chloride in water to hold growth. Over here is a picture of like the type of system setup that we would have, where the water lines are just diverted to this holding tank where we can add the ammonium chloride at the accurate percentage, and then just gets pumped back into the water line for the pigs. Our primary reasoning for doing the water application is for that quicker implementation. Obviously, if a stop movement or slaughter plant shutdown occurred, the bulk bins are still full of feed, most likely for the pigs. And so it would have to wait for those bins to be emptied in order to implement the feed strategy. And so a lot of producers already have medicated water lines. And so this would just result in a quicker implementation until those feed bins were emptied, and then the feed strategy could be used. And then in addition to that, we have some assessments to do on management concerns. Those including skeletal issues. Obviously, we don't want any lameness issues as the pigs are growing. We want to make sure that they can walk on and off the truck. And so we're actually doing DEXA scans on the pigs as well in order to look at any potential skeletal issues. Ulcers and loss of renal function. Again, we have not seen this in our pigs yet, but we know that it could be a potential concern just based off of previous research in like the rats and humans. And so we want to make sure to try to address these concerns, and if it's going to be a potential problem, we want to try and analyze that before we make any confident decisions. And then as well as changes in carcass composition, whether or not they're going to be more lean or not, and then aggressive behavior. So again, all things that we have not currently observed, but they are on our radar because we want to make sure that we are addressing these in case that they could be potential issues. All right, to stay up to date on our research, we are doing research updates periodically posted in the Wisconsin Pork Association Pork Headlines newsletter. You can also contact either myself or Dr. Tom Crenshaw. And then before I end, I would like to make some acknowledgements. Again, we received funding support from the USDA, the National Institute of Food and Agriculture grant. It was part of like a COVID-19 rapid response program. And we would also like to thank Wisconsin Pork Association for their work in helping us to achieve that funding. And then Dr. Tom Crenshaw's lab, as well as the SRTC crew for being the hard work behind the project and making sure that everything is working properly and goes smoothly. Dr. Shavas and Dr. Stevens from the Ag and Applied Econ department for their help in that development of the economic model. And then lastly, different industry professionals who, especially at the beginning of this project and when it was still in the works, excuse me, were provided incredible guidance and were kind of our insight into the industry. You know, they're out there working with the producers, and so they were able to provide feedback to us about what's going on, what different strategies producers are trying to use, what's working, what's not working, different things that we need to, we should address. And so we definitely couldn't do it without their help, kind of providing us that insight into the industry. And that is all I have. Again, if you have any questions, feel free to reach out. And we look forward to being able to post future updates on how the rest of our project is going.